Hello, my amazing math students. This is Mrs. A, and I love math. We are back with lesson 90 in our Saxon Orange math book. We're on word problems with two statements of equality. Another way this could be said is that we are using word problems to work with systems of equations when we have two equations and two unknowns. So here's the first example. Charles and Nellie picked 92 quarts of berries together. And Charles picked 6 more quarts than Nellie. How many quarts each? Well, we're going to make two equations. Now, I like to use variables that mean something to me. You'll see that your Saxon book will use in a lot. Like they would say, number of berry quarts that Charles picked and number of berry quarts that Nellie picked. I just don't enjoy doing that as much as Charles and Nellie. However, they are both exactly the same. It matters not whether you use number sub C or number sub N, or whether you use a C to represent Charles and an N to represent Nellie. It makes absolutely no difference whatsoever. So unless you are specifically told that you must use subscripted variables, you're certainly free to make up your own name for your variables. Saxon books just kind of have a propensity for these subscripted variables. It's a preference, and I don't happen to share it. So you can do yours the way that your teacher prefers that you do it. I let my students use variables that make sense to them. Your teacher may prefer that you use the subscripted variables that are in your book. You need to do what your teacher would like you to do because your teacher's in charge of you. All right, so maybe someday you'll be a teacher and then you'll be in charge of your students and the way they do things. So here we have Charles and Nellie. I'm going to use C and N to represent the number of quarts that each one of them gets. I know that the number of quarts that Charles gets plus the number of quarts that Nellie gets add up to 92. I know that. Okay. I know that Charles picks 6 more quarts. So Charles's is the same as Nellie's plus 6. He has 6 more. So 6 added to Nellie would give you the number that Charles had. We're trying to figure out how many quarts they had. So we're going to do a little substitution here. Instead of C plus N, I'm going to take the C variable and I'm going to replace it with N plus 6. So when I do this substitution, I'm going to get N plus 6, and sometimes I like to put that in a parenthesis so that I know that that was a substitution for the variable C plus N is 92. And we wind up getting twice N plus 6, so twice N plus 6 is 92. Now, I've got it a little bit of crowded because I put all this gobbledygook up there, so I'm going to take this down. So I have a little bit more room to finish up. And since I've got twice N plus 6 is 92, I want to subtract 6 and subtract 6. So I get twice N is 92, take away 6 is 86. Okay, and then I divide by 2, and I divide by 2, and I get Nellie had 43 quarts. Okay, and then Charles has the 43 quarts that Nellie had plus 6 more. So Charles has 49 quarts. So let's put Charles is 49 quarts because he's Nellie plus 6. And then let's do a quick compare and add these two together. 9 plus 3 is 12, which gives me the 2. Carry the 1. 4 plus 4 is 8, plus 1 is 9, and I get the 92 altogether. So we now know for sure that Nellie had 43 quarts of the 92, and Charles had 49 quarts of the 92. Let's look at example 2. Here's our second example. The number of boys exceeded the number of girls by 7. There are 29 students total. How many are boys and how many are girls? Okay, so we're going to write, big shocker, boys and girls. Okay, so don't we know that the number of boys plus the number of girls gives us the total number of students? So boys plus girls equals 29 because that's the total number of students. All right, I know that the number of boys exceeds the number of girls by 7. So if we take the number of girls and we add 7 to it, won't we have the number of boys? Okay, so the boys are greater by 7. And now we have our two equations. So we're going to use substitution again because this one is already solved for B, so that one makes sense. So we're going to go ahead and substitute for the B. So I'm just going to put a little parenthesis to note that this G plus 7 is now being substituted for the B, plus the G is the 29. And we're going to add these two G's together. There's no reason to keep this parenthesis there. I can remove it right away. I don't have to put it there. I'm just putting it there so that you know I'm substituting in. And G plus G is 2G, so we have 2G plus 7 is 29. But I'm trying to figure out what the G is, and so I'm going to subtract the 7 from both sides. So I wind up with 2G on the left because this goes out, and 29 take away 7 would be 22. I'm going to divide by 2 and divide by 2 so that I get the number of girls is 22 divided by 2 is 11. So if I have 11 girls, 11 plus 7 is 18 boys. So boys is 18. And now I'm going to add them together to see if I do indeed get 29. And I do. So there is your work with your equations. Aren't those fun? I think so. Okay, here's example 3. A 38-meter rope was cut into 2 pieces. The longer piece is 9 meters longer than the shorter. What are the measures of each? Again, I'm going to use longer, L, and shorter, S. So longer plus shorter equals the total length of the rope, which is 38 meters. Okay, and the longer piece is the shorter piece plus 9 more meters. We always have to make sure our units are the same. That was meters and that was meters, so we don't have any problem. Okay, so now, again, this one is going to be already set up for substitution, isn't it? Sliding the L right into there is the easiest way to do it. So instead of the L, I'll put S plus 9 plus S equals 38, copying my base equation over and subbing in my substitution for the L. So now we have S plus 9 plus S is 38. So here, there's no reason to keep this here. I can get rid of it or not put it down to start with if you'd like. 2S plus 9 equals 38. So the first thing I'm going to do is subtract 9 and subtract 9. When I do that subtraction, I'm going to get 2S is 38 take away 9 because I already subtracted 9 here and subtracted 9 here. Just because I ran out of room on my board, I'm going to let you do that in your head. 38 take away 9 is 29. I do believe. Okay, so 29 divide by 2 and divide by 2. So the shorter is 29 divided by 2. Well, we know 30 divided by 2 would be 15. So this is going to be 14 and 1/2. So if the shorter length was 14 and 1/2, and then I'm going to add 9 to the 14 and 1/2, the longer length is going to be 14 plus 9, or 23 and 1/2. So now let's see if we're right. If we add 14 and 1/2 and 23 and 1/2, we're going to get 37, 38. And 38 is what we started with. That's the rope before we cut it. That is example 3. And now we're ready for example 4. All right, this is a fun one. This is number 4. The sum of two numbers is 72. The difference of the two numbers is 26. What are the numbers? Okay, so I could label these as X and Y. I could label these as 1 and 2, but I'm going to label them as larger and smaller because it says that the difference of the two numbers is 26. So I'm going to say larger number, take away, smaller number is 26. Okay, isn't that true? And then the sum of the two numbers, larger number plus smaller number, is 72. Okay, now on this one, even though I could very easily do a substitution, I'm going to do elimination because it's already set up for elimination. L minus S, L plus S. Let's add the two equations together like they are right now. L plus L is 2L, but negative S and a positive S cancels the two S's out, and I'm adding these, and I'm getting 98. So twice the larger number is 98. So divide by 2 and divide by 2, and I get the larger number is 49. So if the larger number is 49, then I can come right here, and I could say larger number is 49 plus S is 72. So isn't S going to be 72 take away the 49, and 72 take away 49? That's going to wind up giving me 3 and 2. So the smaller number is 23. And when I add the two numbers together, don't I get 72? And I do. So when I add them together, I get 72, and it is correct. So there is example number 4. I hope you're beginning to get an idea of how much fun these are and how easy they are to work. Now this is number 5, and this is the type of problem that I call fun because it's getting a little bit more complicated than you can just do in your head. Okay, the greater of two numbers is 16 greater than the smaller. When added together, their sum is 4 less than 3 times the smaller. Find both numbers. Okay, so the greater we'll call larger. Okay, so we're going to call the larger number and the smaller. The greater of two numbers is 16 greater than the smaller. So it would be the smaller number plus 16 more. The greater number, or the larger number, is 16 more than the smaller. When added together, so we're going to say L plus S, their sum is 4 less than 3 times the smaller. Okay, 4 less than 3 times the smaller. So 3 times the smaller would be 3S. So now I'm ready. Okay, I have a substitution variable right here. Now notice that I have an L plus an S, and then over here I have a 3S. I'm going to go ahead and just take away an S from both sides. So now I have an L equals 2S minus 4. And I have an L is equal to S plus 16. Now, I'm going to use a little trick that we haven't done yet today. Since I have an expression for L, and I have another expression for L, can't I set this L equal to that L, which means that this S plus 16 must be equal to 2S minus 4. Okay, so I'm substituting the L's for the L's. So I'm setting these two equal and these two equal. So that means that S plus 16 is the same as 2S minus 4. Okay, so now because I'm trying to get the S's in one place, I'm going to go ahead and subtract an S and subtract an S. So I just have one S in the equation. So now on this side, on the left, I have 16 equals 2S minus S is just S minus 4. Okay, so now I'm going to add a 4 and add a 4 to the other side. And I get 20 is the smaller number. Now, if 20 is the smaller number, I can go right back here. I can plug in a 20, and 20 plus 16, or 36, is the larger number. So we'll put that right here. Larger number is 36. Smaller number is 20. Now let's see if we met all of our qualifications. Okay, the larger number, 36, is 16 more than the smaller number. Yes. When they're added together, I'm going to get 56. And is that 4 less than 3 times the smaller number? 3 times the smaller number is 60, and 4 less than that is 56. And that's what I get when I add the two together. And so we found both numbers. And wasn't that fun? That one was a little bit spicier than the last one, a little bit more difficult, a little bit more of a challenge, and I do like a challenge. So we have one more example, and then we have some practice problems. Okay, last example. The ratio of two numbers is 5 to 4, and the sum is 63. What are the numbers? Well, again, we have a larger and a smaller number. So can I say L is to S as 5 is to 4? I can, can't I? Okay, and then the sum of the two numbers is 63. So L plus S is 63. So now let's look at this. We have proportion, and we can cross multiply on a proportion, and we could get 4L is equal to 5S. Okay, and then we could do some substitution if we want to do that now. And then L plus S is 63. So let's go ahead and take this one and solve for L. So I'm just doing it what seems to be the easiest way. So we're going to subtract S and subtract S. We're going to have 63 minus S. And then we're going to take this L and plug it in right here. Now, before I do that, can I just, instead of having 4L, could I just divide by 4 on both sides? So now I just have L equals, and then over here I have L equals. How about we do that last trick again? So we have L is equal to something and L is equal to something. So let's take the two somethings and stick them equal to each other. So we have 5S over 4 equals 63 minus S. Because L equals L, that means that this expression for L must equal this expression for L. Okay, so now just because it's easier to deal with something that's not fractions, I'm going to go ahead and multiply both sides by 4. When I multiply this side by 4, of course, this cancels. And when I multiply this side by 4, I'm going to get a big old number, but that's okay. So this one cancels and we get a 5S. I'll put it way over here. And then 4 times 63, 3 times 4 is 12, carry the 1, 24, 25. And then minus 4s, because that, remember, is an s, not a 5. So minus 4s. So now, since I have a minus 4s and a 5s, let's just add a 4s to this side and add a 4s to this side. And I end up with a 9s equals 252, because these go out. And now we're going to take and get s by itself, so we're going to divide by 9 and divide by 9. So 252 divided by 9. Divided by 9. 9 into 27 is 3, so this is going to be 2. 2 is 18 with a 72, and that's going to be an 8, isn't it? 8 times 9 is 72. All right, so now we're going to take this and we're going to replace that with a 28. So the smaller number is 28. Okay, so we're going to check here. And remember that the smaller number plus the larger number gives you 63. So that means I could take 63 minus the 28 and it would give me the larger number. So what is 63 take away 28? And 13 take away 8 is 5. And 5 take away 2 is 3. So 35 and 28 are our numbers. Well, let's see if it fits into all of the pieces and parts here. Is this a 5-to-4 ratio? Is 35 over 28 a 5-to-4 ratio? Well, it is, because that's 5 sevens and that's 4 sevens. So that fits that. And are the sums of the two equal to 63? And they are. So we have the correct answer. 35 and 28 are our two numbers. We have some practice problems for you to work. All right, students, here is your first practice problem. So I hope you do this by yourself before you watch me do the problem. You're going to learn much better and be much better able to do your own work if you do it by yourself first. So pause your video and go do it yourself. Go on, do it. All right, so hopefully you did that. And now we're looking at the sum of two numbers is 98. And the difference of the same numbers is 40. So again, we have a larger number minus the smaller number is 40. And the larger number plus the smaller number is 98. It's as simple as that, okay? So now, since this is already set up for elimination, I'm going to use elimination. I'm going to just add these two together since I already have opposite signs. Twice L is 138, and divide by 2, divide by 2. The larger number is going to be, let's see, 140 would be 70. So this will be 69 because it's 1 less than 70. So 138 divided by 2 is 69. We go back and we say, oh, the difference between them is 40. So I'm going to take 40 from that to get 29. So the larger minus the smaller is 40. And when I add the two together, I do get 98. So we have solved our first practice problem. Hopefully you got the same two numbers. All right, so here is the last problem. And because I have done every other problem with variables that I wanted, I'm going to do this the Saxon way and use subscripted variables just so you'll have a good example. The number of boys exceeded the number of girls exceeded the number of boys by 11. So we're going to say the number of girls exceeded the number of boys by 11. So if I add the number of boys plus 11, I will get the number of girls because the number of girls is greater. If there were 37 total pupils, so the number of girls plus the number of boys is 37 total. How many are boys and how many are girls? So here we have a good substitution because we already have number of girls separated on one side of the equation. So I'm going to take the number of girls in my core equation here, and I'm going to substitute in NG. So we're going to substitute NB plus 11 in place of the NG, plus NB is 37. Okay, so now NB, and there's no reason to keep the parentheses there, so NB and NB is twice NB, plus 11 is 37. So now I'm going to subtract 11 and subtract 11. So I'm going to get twice NB equals, subtract 11, that goes away. 37 minus 11 is 26. So 26, and then divide by 2 on both sides, and I get number of boys is 13. Okay, now number of girls is more. So number of boys, 13 plus 11, means that the number of girls is going to be 13 plus 11, which is going to be 24. And then I check, do these total together give me 37? And 13 plus 24 is indeed 37. So that is our last practice problem. Hopefully you've learned a lot. This is Mrs. A, and may God bless your day.